How can I lower my environmental footprint? The aim of the investigation is for students in Year 4 to use mathematical strategies to find out if taking public transport has less environmental impact than driving a car to school every day. Through mathematical problem solving, students will measure how much CO2 emissions the bus and car use on a 5-day trip to school. Findings will either support the bus or the private transport using less CO2 emissions and having less impact on the environment. Beginning the lesson with an explicit instruction focus of, today you will be learning how to calculate and compare the CO2 emissions of a bus and car using subtraction, multiplication and addition, will allow the students to know exactly what they will be learning. By providing an expectational outcome of, by the end of the lesson you will be able to decide if a bus or a car is better for the environment, children know what they are working towards and what they must achieve. A warm-up or a revision of prior knowledge such as multiplication, addition and subtraction with 1 and 2 digit numbers will give students a clue as to what math concepts they will need to solve the problem. Children will be asked questions from Bloom's taxonomy to promote their thinking skills and gauge their comprehension of the topic. What facts do we need to solve this problem? How could we show our working out? What concepts can we use to solve this problem? These will be brainstormed as a class on the board. This provides an opportunity for students to demonstrate higher levels of thinking and understanding. The brainstorming will get students to use strategies to identify key elements of the problem. Children will be provided with handouts that detail the relevant facts they need to solve the problem. Discussion will take place around whether it is easier to solve multiplication and addition problems with numbers ending in 5s and 0s. Students will be asked if it is easy to use numbers that end in 5 and 10 when adding or multiplying. They will be encouraged to think about how they could make the sums easier. For example, what could they do to the numbers to make them easier to use in their sums? This question will help children expand their problem-solving skills and think about place value. Students should answer that the numbers could be rounded. Brainstorming the steps that are needed to solve the problem will emphasise that problems need to be solved in order. Children will be able to see that the problem is simplified by identifying the steps needed. This will give children confidence in solving the problem once they see it broken down. Asking children to share their ideas orally allows for the teacher to visually see the children's strategies. Remind children and show on the board how the problems should be recorded. Refer to the brainstorming to remind them they need tables. This is as per the Australian Curriculum Standard of construct suitable data displays from collected data. The first step is to identify the distance to travel one way to school. I would ask how they can find out how far they travel to and from school in one day. Once they have identified that it is 30 kilometres to school and 30 kilometres home, I would ask them to come up with an equation. This is in line with the Australian curriculum of solving word problems involving multiplication. Using Show Me boards here allows the students to investigate the problem several times and is more engaging than bookwork. After allowing the students to have a go themselves, we would work through the problem on the board. 30 multiplied by 2 means that I have 2 groups of 30. Set out the operation vertical, remembering to line up the place value columns correctly. The operations are consolidating place value. I would explain to the students that I can put the 0 in storage and simplify the problem to 3 times 2. Recall your multiplication facts. 3 times 2 equals 6. Take the 0 out of storage and place it on the end of the 6 to become 60. 30 times 2 equals 60. This problem shows children how partitioning numbers can be used in operations, as 30 was partitioned into tens and ones, and includes the proficiency standard of fluency, that is recalling multiplication tables. Children would be encouraged here to work by themselves to problem solve the CO2 emissions, with the teacher monitoring and offering help where needed. For the first problem in this step, I show the children an example on the board. Complete the car emissions per day using the correct terminology and working out 130 grams multiplied by 60 kilometres. For example, there are 2 steps to the problem. First, we must multiply by 0 and then by 6. We know that if we multiply a number by 0, the answer will always be 0. So 130 multiplied by 0 equals 0. Next, we must multiply by the 6, which is actually in the tens column. So we need to place a 0 in the ones column, because we have already multiplied by the ones column, which was 0. 6 times 0 equals 0. Place down a 0 in the tens column. 6 times 3 equals 18. Place down an 8 and carry the 1 next door to the hundreds column. 6 times 1 equals 6. Now add the 1, which equals 7. Now we must add the new numbers together. 0 plus 7,800 equals 7,800. Solving the problem through written operations allows children to clearly explain their thinking. Solution tables should look like this. Draw an example on the board. Bringing the children back together as a whole here would be beneficial to talk about what operations are needed to compare quantities, reminding children that they are measuring something and discuss how they can find out the difference is important. Modelling the correct use of terminology is also important for children to learn and use language of mathematics and is one of the 5 principles of how students should learn maths. We must take the smaller number away from the larger number. 2,028,000 take away 1,404,000. I would start the subtraction with 0 take away 0 equals 0, 0 take away 0 equals 0, 0 take away 0 equals 0. Remember to place the numbers in the correct place value columns. 8 take away 4 equals 4, 2 take away 0 equals 2. 0 take away 4 we can't do, so we must go next door and get some more. Take away a 1 from the 2 becomes a 1, and we give the 1 we borrowed to the 0. We now have 10. 10 take away 4 equals 6. 2,028,000 take away 1,404,000 equals 624,000. This problem links with the curriculum of solving multiplication problems using efficient mental and written strategies and represents numbers to at least tens of thousands. I would ask the children to write the solution to the problem in sentence form. Students should come to the conclusion through mathematical problem solving that a lower environmental footprint is left by taking the bus to and from school every day as opposed to driving in a car. Taking the bus over driving a car lowers the CO2 emissions by 624,000. Less CO2 emission means cleaner air, less smog and a better environment. The mathematical problem, public transport versus private transport, aligns with the Australian mathematical scope and sequence of Grade 4. It covers the capabilities of solving word problems using multiplication, recalling multiplication facts using written and mental strategies to at least 10,000. This problem allows students to correlate data in suitable displays such as tables and consolidates previous work on place value. Using show me boards allows the teacher to observe the strategies the children are using and for children to clearly show their thinking through written operations. Proficiency standards are met, including fluency, where children recall multiplication facts and collecting and recording data, along with problem solving, where children are able to formulate and record operations and compare large numbers with each other. Using open-ended questions allows students to come up with different ways of solving the problem and are asked to apply what they already know to a new mathematical situation. These questions allow for multiple views of the problem. Each mathematical process is completed individually and recorded in tables to keep working out clear and easy to read. The implicit instruction is designed to promote achievement for all students by providing clear statements about the purpose and rationale of the lesson.